This week, we're going to be covering the 242nd LeetCode problem, valid anagram. This question is super popular, and you can tell easily by just looking at the LeetCode's like to dislike ratio. Now, if the like to dislike ratio is ever above like 85 to 90%, it is a great question, especially with over 900 likes on this question. Now, I do want to mention that it is an easy level question, so if you're interviewing at companies like Amazon or Google or Airbnb, you might get this question in conjunction with a medium or hard level LeetCode question in a 45-minute interview period. That being said, this is still a great question to cover. So let's get started by reading the problem statement. So the problem states, given two strings, s and t, write a function to determine if t is an anagram of s. So what is an anagram? An anagram is just the same letters of the word rearranged. So here, s is equal to anagram, and t is equal to N-A-G-A-R-A-M. Basically, t is a rearranged format of s. So we know that it's a valid anagram, so we output true. In example 2, we realize that rat is not a valid anagram of car, so it is false. Now let's think of an algorithm that can help us solve this problem. So if we're given string 1 and string 2, and we want to check if they're valid anagrams of one another, a simple solution would be to just sort these strings. And once we sort these strings, we can just check if they're equal to one another. However, if we think about the time complexity, that's going to be n log n to perform a merge sort on these two strings. Now there is a faster way to do this problem. That method is with using a hash map. What we can do is iterate through the values of the string in S1. While we're iterating through the values in the string, we can update the hash map. So the key is going to be the character in the hash map, and the value is going to be the number of times it occurs. So after the first iteration, we will be on A. We will see that the hash map is equal to this. In the second character, we're going to have a, 1, n, 1. In the third iteration, we will have a is equal to 2, n is equal to 1. And we can go and continue filling out this entire hash map, which is going to contain the characters and the number of times each character appears inside of the string. So once we have this hash map, all we have to do is iterate through the second string, and we want to subtract the values from these hash map. In this case, every time we see an a, or let's say we see the n, right? We're going to subtract the value of n by 1, so now it's going to be 0. And then we see an a, so we're going to subtract the value of a in this original hash map, and we're going to have a is equal to 1. So let's go through a quick example. Say we have a, b, and b, a. So the first hash map is, the hash map is just going to be a, 2, b, 1. When we are iterating through the second string, we see b, so we're going to find b in the hash map and decrement it by 1. So now the hash map is going to be a, 2, b, 0. Now we're done with b. So now we go to a, we realize that a is 2, so we decrement it, so a is 1, and then we check this a, and we're going to realize that we have an a, so we're going to set the count to 0. So now, at the end, all we have to do is iterate through the hash map's keys, and for each key, we just have to make sure that the value at the key is equal to 0. That means that S1 and S2 are valid anagrams of one another. So the original algorithm where we used a sorting to compare would have been O of n log n. Now that we are iterating through the hash map with S1 and S2, so we're going to go through the whole length of S1 and S2. We know that in the worst case, both of these are of size n, and if they're both of size n, since we're only iterating through them once, it will be n plus n, which in the end is just going to be big O of n. And now for space complexity, we may have to store all n unique possible characters in the hash map, which in the worst case is going to be O of n. Now in the problem, it did say that only lowercase letters would be used for this expression. So that actually implies that at most 26 characters can be inside of this hash map, which actually means that the space complexity is going to be constant. Now, this is not necessarily going to be the case. If there are infinite characters, if there are n different characters, then we would have a space complexity of O of n. But since we know that they are all lowercase characters and there's 26 characters, we're going to have a constant space algorithm and a linear time algorithm. Now that we understand the algorithm and the big O time complexity, let's jump into the coding section. So the coding section is pretty straightforward. There's only 3 things that we need to account for. Of course, we obviously have to declare an empty hash map. And the first section is just going to be iterating through the first string and counting the number of times that each character appears in that string. Second section is also pretty simple. We're going to go through the second string and we're going to decrement the number of times each character appears in that string. Lastly, we just want to iterate through all the keys in the hash map. If any of them contain a key that is not equal to 0, then we return false. So that can either happen if a character exists in T that does not exist in S, at which case we create this character and it's -1, or an extra character exists in S and it does not exist in T. So these are going to be the 2 possible cases where we would return false, or of course the length of both of the strings are different. So those are the 3 cases where we might return false, and if we have not returned false already, then we know that the 2 strings are valid anagrams of one another. So we just have to return true. Let's just submit and make sure that it is running. Actually pretty slow. I ended up getting a runtime that was 24 milliseconds, which was faster than 98% of all Python submissions. Anyway, hope you guys enjoyed. If you did, leave a like and subscribe for more in the future. I post weekly on Mondays. Thanks for watching, and I'll catch you guys next time.